Any questions? Yes, Ty.
On the mastering set, there was a question that involved finding the linear density. Can you give
Right.
an example of it? I think it gave you the frequency.
Sorry. So the speed of a wave we can find two different ways. If we know the frequency and wavelength, that's one way. And the other. You done?
No.
And the other is tension over the linear density. So in that particular question, I forget what you were given, but let's see.
You have frequency of 60 hertz, a distance of 1.2, and a tension of 100 G on the string.
All right, so you have tension. It's probably tell you the harmonic.
No, it says that you have 1.5 wavelengths.
Okay, so 1.5 wavelengths over 1.2 meters. All right, so if I have 1.2 meters and 1.5 wavelengths, then I can figure out what a wavelength is, so I can find that from that information. And so you're just solve from you to this equation here.
I forgot the center part of the board
Is that sufficient, or do you want me to actually run through and sample calculation?
I think that I got it now that I guess I just forgot about that second half.
Okay. Other questions? Okay. Yes, Ashley.
For this week, what videos were we supposed to watch? The thermodynamics or the electric and magnetism?
You should be at least through the thermodynamics by, I guess, Friday.
By Friday?
Yeah.
Okay.
When we submit the syllabus before the course even starts, it's making assumptions that has nothing to do with who you are and what the class is like. So I just take a shot at it, knowing that it's gonna change.
Okay, so when would that, because the master set due date for that one has like September, so is that due next week?
Yes, what's a reasonable day next week?
Tuesday.
I heard Tuesday.
Next Tuesday, next Thursday.
Tuesday's a good day.
Tuesday's a good day? It's good? All right, I'm here at Groundswell for Tuesday. Yeah, so you could get it to me by September, but it'll be a bit late for the grades.
Or just turn it in for your for like the next time you take the class.
That could be too.
And, you know, take it the next fall semester and then get to you early.
I have had students in the same course multiple times, and there are occasions when I have used sort of scores from the previous semester for the current semester.
Your test is on Thursday, correct?
Say it again?
Test is on Thursday, correct?
That multiple choice test? Sure. I couldn't remember if it was today or then, or Thursday. Did we say today?
Last week you said Thursday.
Thursday.
Because the reason why we wanted to turn in that master set
Okay.
Tuesday was because we had the test on Thursday.
Okay.
And our third test, would that be the first or, would that be the second? Our
What?
third test? March 2nd?
No, the
multiple choice is this Thursday.
yes, the 23rd.
Yes.
And the last test would be the one where you need a calculator kind of thing would be Thursday the 2nd.
Okay.
That's the last time we meet face to face.
So We won't even need a calculator for that?
No, you don't need one for this Thursday, you'll need one for Thursday of next week.
You're telling me I stole that calculator from my sister for nothing? That's crazy.
That's between you and your sister.
And that will be
I won't tell her
chapter
to do
19 through,
It'll basically be, even though we did 19 through 21 first, it'll be 15 through at least 21.
For next Thursday or this Thursday?
Thursday of next week. Which gets into a traditional of next Thursday, is that I always think of next Thursday as the next Thursday we come across, which is in 2 days. Other people say next Thursday means Thursday of next week.
I use, in 2 days, just this Thursday, next Thursday is the one.
Yeah, I seem to be in a minority on that, on my interpretation. But it does lead to some zany miscommunication,
Yeah, I can see that.
like a rom-com.
So what chapters will this Thursday cover? Chapter 2 up until
2 through 5 primarily.
just 2 through 5?
Yeah, there's some circular motion in it, which officially in Hewitt's book is chapter 20, it's not 20, where's that coming from? Chapter 8. But that's just an application of stuff from 2 through 5. Right. Other questions? All right. We last left off. All right, so when I put energy into a system, and you can think of the system as I've got let's say a block of aluminum and I light a fire underneath it. Somehow there's energy transferred in because of a temperature difference. What's going to happen if I put a fire underneath the cube of aluminum?
it will warm up.
Okay, that's one thing. And what's the other one?
Could change in size a little bit, maybe.
Okay. And if I put heat under it, what's the aluminum going to do? You said change size, more specifically?
Burn?
Melt?
I hope not.
Like the difference between molecules will expand just that.
Okay, the aluminum should get bigger. What's a substance that will get smaller if heat is applied in certain situations?
Plastic? Gets smaller when you burn it?
No, I guess it does sort of shrivel. But that's because the plastic is, what's that some type of plastic? Okay. I'll buy it. I was thinking ice, but. All right, so we have the two things that might happen. And so I put heat in. So Q, the symbol for heat. It is energy. Because it's energy, what would be the units of Q? All right. So I put it in, and so I could have expansion or deflation. There's a change in size. And then there's a change in temperature. Capital T for temperature. The same symbol we use for period, but we don't have any problems which involve period and temperature, so we're good there.
Does that say delta L?
Yes, I was trying to, there's a change in the length of the volume or area. And we had last time a formula that apparently didn't like what I did. That the change in length, if you were dealing with something that's long and skinny, is equal to some coefficient, depending upon the material, times the initial length times the change in temperature. And so let's just do a specific problem here. There's all change in temperature problems. So there was a video from last Thursday, whenever we last met, that I posted on Thursday. 1.6 thousand views in a couple of days. Either a glitch in the counting mechanism or somebody just thought, you know what, let's just give this person a whole bunch of views for this video.
That was me, sorry.
Say again?
That was me, I'm sorry.
Oh,
Yeah.
okay. No need to apologize, you know.
Somebody just had it running on repeat in the background. Left it on.
Seems- If you don't have to use your computer for anything else, sure. All right, so if we're talking about aluminum, alpha is 24 times 10 to the negative 6. No units on top, and then per degree Celsius on the bottom. So if I take an aluminum bar, and may as well stick with the dimensions I have written here. So I got if it's a 0.003 meters, in other words, 3 millimeters, by 0.002 meters, by 3.0804 meters. So if that's the initial dimensions of it, the reason why these are so small is I wanted these to be really small in comparison to the length of it, so we could pretend it's a one-dimensional object. In reality, all 3 dimensions will expand, but we only really care about one of them. So if I change the temperature from, let's say, 20 degrees Celsius to 60 degrees Celsius, how long is the bar now? So if this is the dimensions at 20 degrees Celsius, so at 20 degrees Celsius. Well, while you judge, 24 times 10 to the negative 6 per degree Celsius. That's alpha times L sub 0, the 3.0804 meters, times the change in temperature. What's the change? Give me the whole thing.
40 degrees Celsius.
There we go. You might have said the last part, but it was very faint. Now, unit-wise, let's just make sure that the units work out. I got a degree Celsius on the bottom there, and I got a degree Celsius on the top here, so my degree Celsius can go away. And all I'm left with on the right-hand side is meters. So I'm gonna have a change in length in meters, which makes sense. So if you plug it into the calculator, what you get? That's not it. same thing? Anyone else? I got a nod back there, got another nod here. All right.
Yeah.
So this thing is 3 meters long. Now my height is under 2 meters. The 3 meters is roughly floor to ceiling. And if I change the temperature from 20 degrees Celsius to 60 degrees Celsius, it will expand almost 3 millimeters. Which is approximately 3 millimeters. So it's not going to expand a whole lot. Now, if I got a bunch of these beams here, so if I'm creating a building, constructing a building, then yes, it might start to matter if everything shrinks or expands. Now, I hope we aren't having anything expand out to that temperature, which is very crudely 150 degrees Fahrenheit. And that's roughly room temperature. As a side note, given the original dimensions there at room temperature, what's the mass of this aluminum bar? Or how would you find it? What is the quantity that relates? I got dimensions here, so what can I find with that? If I had a length, width, and height, what can I find with that?
Area or perimeter.
Volume. I got 3 of them, 3 dimensions, volume. So if I multiply those together and get my volume of my aluminum bar, so length, width, height, and which one's length, which one's width, and which one height, mathematically, it doesn't matter. So if you multiply those out, what do you get? It'll be something small.
Zero 0.00001848.
Is that the right number of zeros?
Yeah.
Okay.
Oh wait, no,
I
there's
have
4
one
zeros.
more zero. I have 4 zeros.
4 zeros.
Units?
Meters cubed.
Yeah. Each of those is meters, so it is meters cubed. All right. Now I'm trying to find the mass, and I have a volume. What quantity associates mass and volume?
Density.
Yep, that's the one. So density is mass over volume. Well, density is sort of material specific, and for aluminum, it's one of the ones I just happen to know, is 2,700 kilograms per cubic meter, or 2.7 grams per cubic centimeter. Now, your textbook will give it to you in kilograms per cubic meter. A lot of sites will give it to you in grams per cubic centimeters, because this typically is the one those units are typically used, even though it's not standard international. But grams per cubic centimeter was the standard for years, and there are a lot of sources still there. All right, so that is going to be equal to my mass divided by my volume of 0.0001848. So my math problem is 2,700 over 1 is equal to x over 0.1234184. That's the math problem. And with overuse of the letter M, do recognize that this M right here and this M right here are not the same. This is mass and this is meters. So how would you solve this?
Multiply by your volume,
Okay.
by your density, by your volume.
Yep, so you're or from a math point of view, I got two fractions equal to each other. You multiply the diagonal, you know, divide by what's left over, which is a 1.
Zero, 4, 9, 8,
9896 units.
kilograms.
So if we converted that into grams, since that seems to be more appropriate here, how many grams is that? How many decimal places do we move over?
3.
Yeah, 3. So it's 49.896 grams. Roughly 50 grams.
So do you accept either grams or kilograms?
Yeah, they're both correct answers. If I don't specify, either one's fine. And while we're here, how many cubic centimeters is this? How many decimal places do I move it over to convert this to cubic centimeters?
2?
3.
So I got 2, 3, and 2. Anyone want to say what the right answer is?
1 meter. Oh, it's 100 centimeters, right?
Yep, 1 meter is 100 centimeters.